Hello guys. So guys, we'll be implementing one amazing project called facial emotion detection with the help of YOLO 11. So this is going to be a computer vision project. So here we'll try to detect actually various kinds of emotion. So we'll be using one amazing actually emotion, facial emotion dataset. And I will also show you the dataset, like how this dataset looks like. So in this video, first of all, I will give you the project introduction and the data overview. Even I will also show you how we can train the model. And after training the model, how we can, let's say, download the model in our local machine. And in our local machine, how we can do the real-time, let's say, detection operation with the help of our web camera. So this is going to be one amazing implementation, guys. So make sure you complete this video. And apart from that, if you want, you can also update this project. If you want to add some new features, you can also add it. Okay, it's up to you. So what is facial emotion detection, guys? I think you know. It is nothing but, let's say, there is a human, and this human is having actually different facial expression, like we see like happy, angered, sad, confused, right? Then bored. So these kinds of actually, let's say, image you can collect, and you can train one object detection model. But again, see, this is not a actually efficient way to do the facial emotion detection, because here we are doing the object detection, and I think you know object detection will only create the bounding box, okay, on top of the object pattern. Okay, let's say if object pattern is changing, that time your detection will also change, right? But it can't actually exactly learn whether this person is happy, okay, or this person is anger or not. These kinds of facial expression this model can't learn. Okay, so for this we have to use something called facial model, okay, face model. So in future I will also create some video there. I will also show you how we can use actually different face model, face embedding model, to perform these kinds of actually operation, let's say facial emotion detection. Okay, then we'll be also doing the face detection. These are the thing we'll be doing. But in this video, I want to show these kinds of, let's say, detection can be also done with the help of YOLO 11, because YOLO 11 is like a very powerful model. So this YOLO 11 can also detect a small pattern from an image also. Okay, so that's why I want to show you this project can be done with the help of detection model also. But whenever we'll be implementing this project in the production, we'll try to use the facial model, okay, face embedding model. So I'll show you. Okay, no need to worry. First of all, let's try to see how we can develop this project with the help of this detection algorithm. Got it? So first of all, let me show you the data, like from where you will get these kinds of data, and how to, let's say, download the data, and how to prepare the training notebook. So guys, I'm going to use this data called facial emotion dataset computer vision project. Okay, so this dataset is available RoboFlow Universe. So let me show you. So if you go to the RoboFlow Universe, so I think you know RoboFlow is a platform. It is having different let's say product. So Universe is one of the product. Okay, and inside Universe you will be getting all kinds of computer vision related data, whether it is a computer vision, classification, instance segmentation, key point detection, okay, or semantic segmentation. All kinds of data are available. Even this data set is already annotated. Okay, you don't need to annotate these other data, but if you want to annotate your own data, let's say you have the custom data, that time you can also annotate. For this, I already created some tutorial in my YouTube channel, how to annotate the data with the RoboFlow platform. You can check it out. Okay, even I will also give the link in the description. From there you can check it out. So guys, you can see here you can search actually what kinds of data you need. Either you can also filter out, let's say I want object detection data. I'll simply click on object detection. Now if you go below, you will see that facial emotion dataset is available. Okay, apart from that, there are so many dataset, okay, related object detection. So here I'm going to use this particular data. Okay, you can see this is the data. Now if I show you the image, it is having almost 1227 image, and all the classes you can also see. Like, so if you click on the classes, you will see different classes we are having, like angry is there, disgust is there, fear is there, happy is there, neutral is there, null is there, sad is there, surprise is there. Okay, so here is the image. Okay, they have already annotated this image in the RoboFlow platform, and this dataset is already ready for the training. So only you just need to download, and you have to train the model. Okay, so if you also want, you can also like annotate your own data. For this, I will give the tutorial, okay, how to annotate your own data. But data annotation is the costly task, it's time-taking task. So try to use the existing data if you have it. Okay. Now, if I want to, let's say, get the data, so what I have to do, guys, I have to click on the download project. Now here, you will see one option called download dataset. Okay, just try to click here, and you will see that it will tell you, just try to select the format. Okay, which format you want to download the data. So here we'll be using YOLO 11 model. So make sure you select the YOLO 11. Either you can download as a zip file, okay, either you can download as a code. Okay, so let me first of all download as a zip file, and let me show you the data, how this data will look like. See, it is getting downloaded. Okay, you can see this dataset is getting downloaded. So let's wait. Once the data is downloaded, I will come back and I will show you the dataset. So guys, you can see my data is downloaded. Now let me unzip the data and let me show you what would be the format of the data. So you can see unzip is completed. Now if I show you, so guys, you can see this is the data format. So you have 3 folder called train, valid and test. So if I open the training, and it is having the image and level. So here is the image, guys. So you can see here all the image actually you are having, okay, with all kinds of, let's say, emotion. Okay, and this is the label. I think you know this is the YOLO annotation. Okay, and it will give you one txt file. Inside that you have all the coordinate point with respect to their label. So I already created a tutorial related YOLO in my YouTube channel. You can check it out. Okay, so yeah, so guys, now you can see this is the data, and here you have one data.yaml file. So let me open this data.yaml file. Inside that you have the data location and number of classes. You have 7: angry, disgust, fear, happy, neutral, sad and surprise. And these are some RoboFlow metadata. Okay, so with the help of this data, we'll try to train one model. Okay, YOLO 11 model. And what we'll do after training it, we'll try to download our, let's say, trained model. And with that model, we'll be doing the real-time prediction with our web camera. Okay, so here we'll try to use the YOLO 11 for the detection task. Okay, and I already showed you the dataset. So this dataset actually we'll be using. Okay, and here I have already prepared one training notebook. So here we'll try to see the entire training step, how we can do the training. Okay, and I've already added the data link, and all the resources would be shared in the description. From there you can download. So first of all, what you have to do, just try to connect your notebook with the GPU. So I'm using Collab Pro, that's why I'm having A100 GPU. But if you're using free Collab, that time you can use the T4 GPU. Okay, now let me connect my notebook. Okay, my notebook is connected. Now if you want to check the GPU, so you can execute this command. So here you can see I got A100 GPU. Now the first thing, you have to install the ultralytics, because I think you know, if I want to use YOLO 11, I have to install this package. Okay, ultralytics, because YOLO 11 is available inside ultralytics, and this is the GitHub of ultralytics. So simply just search for YOLO 11 GitHub. So you'll see that it is available inside ultralytics. Okay, that's why we have to install the ultralytics. So they have already given the command. Fine. Now after that, if I show you the ultralytics version and the Python version, because I need it whenever we'll be doing the local setup, that time I need this version actually. Let me show you. So you can see I need to use Python 3.10 environment. Okay, that time. And this is the ultralytics version. Now let me import some of the necessary library. Then after that, we'll be downloading the data from the RoboFlow. So what you can do, either you can upload that zip file you have downloaded in the last video, or you can directly download the data like that. So just click on download dataset, click on the show code, continue, and there you will get a code snippet. Just try to copy and just paste it here. Okay, now if I execute, you'll see that automatically it will download the data from the RoboFlow universe. Okay, so that's how guys RoboFlow makes most of the task easy. Okay, nowadays in the computer vision, that's why I personally prefer a lot. If you want to see the data location, see this is the data location. Got it. Now we'll start the training. Okay, and I think you know, if I'm using YOLO 11, it's like very easy to set up. Okay, so you don't need to do so many configuration. Now see, we can directly start the training, but before that you have to set the data location. So open up the data.yaml file. Inside that you can see these are the location I have to change. So let me change. So let me first of all open the train, copy the image path and try to replace here. Okay, similar wise I will do for the validation. So copy and paste. Then I will do it for my testing. Okay, so copy, just a minute, copy and try to mention it here. That's it. Now just try to press Ctrl S and close it, and after that we can start the training. So guys, now let's start the training. You can see I'm executing this command YOLO task is equal to detect, mode is equal to train, and this is the data location I'm giving. Okay, and this model actually will be doing the fine tuning. Like, so this model actually will be doing the fine tuning. YOLO 11 NPT model, you can see it is having model 2. So this model actually we are fine tuning. Okay, so you can start the training. So what you can do guys, you can increase the epoch size. So as of now, let's train only 10 epoch. Okay, because it will take time. I already trained one model guys, let me show you. So in my local machine it is available. So here Let me show you my model. So guys, you can see I already trained one model, okay, base.pt. So this model I trained around 200 epoch. So in case, actually what you can do, you can mention 200 epoch or 300 epoch, okay. But just to show you in this video, I'm training 10 epoch, okay, just to complete this training quickly, okay. And this is the default image size you have to give, because this image size they use during the training. Now if I execute, you will see that my training will start. So it will download the model, it will load the data, then it will start the training. So guys, you can see my training has started. So one epoch is going on, and you can see the box losses, class losses, okay, everything. Now let's try to wait once training is complete, and I will come back and I will show you the some evaluation matrices as well. Then we'll download the model and we'll do the real-time detection with the help of our web camera. So my training is completed. Now let's do the so guys, you can see my training is completed, and here you can see the MAP score, mean average precision. Now let me show you some evaluation matrices. So if you want to see the multi-class confusion matrix, so it is available inside runs folder. You can see runs folder has created inside that detect and train, and inside wait, I'm having my train model. Okay, this is the train model. So you have to download this model. Just try to click here and download this model, guys. Okay, because we have to use this model in our local machine. And here are all the evaluation matrices graph. Now let me plot some of them and let me show you. So this is the confusion matrix, multi-class confusion matrix, and this is the levels. Okay, like how many levels you are having. Here you can see this is the level distribution. That means we have discussed actually a very less image, okay, in my data set than surprise, okay, and almost all the data you can see it is in a similar distribution. Now if you want to see the results, that means the losses and MAP score, you can see this is the losses is decreasing and MAP is increasing. That means your model is learning well. If you increasing the epoch size, you will see that your model will learn better. Now let me show you some batch images as well. So these are some batch images, and if you want to see some batch prediction image, so these are some batch prediction images. Okay, now what I will do, I'll first of all validate on top of my test data, because you can see I also have the test data. Okay, so let's see the model performance. So here I'm executing, so I'm giving my base.pt location, okay, from this folder, and I'm giving my test data location. Okay, now you can see it is loading the test data and it will do the validation. And here it will give you the matrices like MAP score. Okay, you can see the MAP score. So MAP score should be close to 1. Okay, that means your model is learning, okay, with respect to all the level. Now let's do the inference. Okay, inference on top of my test data. Okay, so here is the command, guys. YOLO task detect, mode is equal to predict, and here I'm giving my train model location. Then this is the source is equal to, I'm giving my test image, okay, and save is equal to true. Now let me execute. So you will see that it will load all the test image and it will do the detection on top of it, and it will save inside runs folder. See, done. If I open the runs, you can see the prediction. Inside prediction, all of the prediction images saved. Now let me show you some of them. So if you execute this command, so if you execute this code, it will load some of the, let's say, predicted images from the folder, and it will show you here. You can see, guys, it is happy, fair, okay, angry. And why a double detection is coming? Because we already because I already trained like this model with 50 epochs. So if you're increasing the epoch size, you will see that it would be pretty good detection. Okay, now see, my model is able to detect, although I've trained 50 epoch. Now you have to train 300 epoch, guys. Okay, whenever you are training, just try to train 300 epoch. After that, just try to download the model, and here you can use this particular code. Okay, you can see, guys, I've already prepared the code. Let me open up my VS code here. So in the readme file, I already mentioned all the command. Okay, you have to execute. So first of all, you have to create an environment with the help of Python 3.10. So this is the command. Just try to copy and try to execute in your terminal. Okay, that's it. So for me, I already created, I'm not going to execute. Then after that, you have to activate the environment. Okay, just try to activate. After that, you will see the facial. Then try to install the ultralytics. Okay, just copy the command and try to execute here. It will install the ultralytics. Okay, once everything is done, okay, once everything is done, open the main.py, and here you just need to keep your base.pt model, and inside that you just need to mention, and source is equal to 0 means I want to utilize my live camera. Let's see, if you have a video file, that time you can give the video file location. If you have an image, that time you can give the image location. But I want to use my live web camera. That's why I've given source is equal to 0. Okay. If you have multiple camera, that time you can also change the source ID. Got it? But by default, if you give 0, it will take the web camera. Okay. So now what I will do, I will stop my camera, okay, in the recording, and I will execute this code, and it will open up my camera. It will do the real-time detection. Let me show you. So I have closed my camera. Now let me open up my terminal and let me execute this command called python main.py. So guys, you can see it has started my camera and it is doing the live detection. Now see, if I show the face like that, it is detecting happy. Okay, it's detecting happy. And if I, let's say, change the okay, I'm not sure like how to show the sad, but let me stop the execution. Okay, you can try actually with different images. So I think I already showed you now. So different image gesture. So from here you can try. Okay, whether it's a sad image. Okay, you can make the face like that and you can do the detection. Okay, and again I told you guys this is not the exact way to the facial emotion detection. So for this we have to use the face embedding model. So detection model, sometimes it won't be giving you the good accuracy. Okay, but at least you can do this kinds of project. Okay, and it is fun. Okay, with the help of YOLO 11 we can perform it. So yes guys, I hope you like this implementation and it was helpful. With that, thank you so much for watching this video and I will see you next time.